The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 degrees Fahrenheit at the planet's core. Unfortunately, you can't land on Jupiter's surface because, well, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They're what make the planet look colorful and kind of striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, becoming liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are minus 234 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 degrees. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 miles per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot. And now, it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color. But so far, it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one, as wide as our home planet, rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. This storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our moon also has some sort of an atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Woo! A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me. But instead of spewing lava, they produce enormous amounts of energy, and this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't get my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2 141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on the K2 141b reach 5,000 degrees during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor into the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. The fastest wind speed ever recorded on Earth was related to a hurricane gust. On April 10, 1996, tropical cyclone Olivia was passing by Barrow Island, Western Australia. At one moment, the storm reached the speed of a Category 4 hurricane, 254 miles per hour. That's faster than a Formula One racing car. You can probably imagine how much damage this kind of wind can cause. The only windstorm faster than that is a tornado. The air inside a whirlwind can move at a speed of 300 miles per hour. Unfortunately, there's no sure way to measure tornadic winds. Weather instruments never survived the experience. Oh, and licking your finger and sticking it up in the wind to measure speed also isn't a good idea here, unless you don't mind losing your arm, or worse. Here are some more numbers. 35 miles per hour and more. That's the speed of the average blizzard. 50 to 60 miles per hour. That's how fast a severe thunderstorm moves. More than 74 miles per hour is the speed of a powerful tropical hurricane. Up to 400 miles per hour? Wait, do such speeds exist? Yep, but you need to travel to Jupiter to see a storm that speedy. The Great Red Spot is an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the surrounding cloud tops. The storm's almost 3 times as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that the monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But since these measurements were most likely imprecise, the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and Jupiter's temperatures are minus 234 degrees Fahrenheit in its upper cloud layers. The closer it is to the core, the hotter it gets. But the highest temperatures ever recorded on the planet were in the atmosphere right above the Great Red Spot. There, the heat can reach 2,400 degrees Fahrenheit. That's hotter than lava on our planet. The storm's extreme conditions and turbulence produce gravitational and sound waves. These waves might be responsible for the superheating. The storm itself is also warmer at its bottom than at the top. If you found yourself at its center, you wouldn't be too impressed. But on the edges, the wind speed reaches 300 to 420 miles per hour. That's faster than Earth's tornadoes. Now, this will help you picture the immense force of such winds. On Earth, the wind doesn't have to be faster than 60 miles per hour to lift a person as heavy as 170 pounds from the ground. A wind as fast as 75 miles per hour can uproot large trees, peel off roofs, break windows, and turn over mobile homes. When the wind speed reaches 150, it can send cars flying. Now picture the havoc a storm as powerful as the Great Red Spot can cause on our planet. But could such an enormous anticyclone occur on Earth? Luckily, not. Our planet doesn't have the unique conditions needed for the storm to form. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. And it was mostly the fault of the storm's home planet. It's more than 1,000 times larger than Earth and over 300 times as massive. Jupiter is a gas giant, which means it consists mostly of fill in the blank. Around the planet's core, there's an ocean of liquid hydrogen. And the atmosphere is also mostly made up of hydrogen and helium. That means Jupiter doesn't have any solid ground, the only thing that could make the storm weaken. Without any friction, the storm has already been churning for centuries. The hot gases in the planet's atmosphere are always moving, rising, falling, and swirling. Just like on our planet, when cooler and hotter gases mix and merge into one another, they form giant circling storms. Astronomers think that once, several enormous storms came together and created the Great Red Spot. And now, it keeps raging by constantly drawing cool gases from below and hot gases from above. Plus, this monster of a storm absorbs other smaller vortices. They make the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow people to see what's going on in the planet's lower atmosphere. Astronomers have been speculating on what may lie beneath the Great Red Spot for decades. Could it be a massive volcano? Unlikely. Jupiter's mostly gas. That's why it doesn't have a crust that could crack and release scorching hot stuff from the planet's interior. Several theories try to explain why the storm has its trademark color. It varies from whitish and pale salmon to orange and brick red. Some scientists believe the answer lies below the Great Red Spot, closer to the planet's surface. A colorless layer of ammonium hydrosulfide might be reacting with cosmic rays or the UV radiation coming from the sun. This somehow gives the spot its pretty red color. But so far, it's just a theory. Astronomers have been observing the Great Red Spot since the 1830s, and for the first time, the storm was spotted in 1665 and described as the permanent spot. In other words, the storm is almost 400 years old. Strangely, it's been shrinking in size since the beginning of the 21st century. In 2019, it began flaking at the edges, with smaller pieces breaking off and vanishing. If this process continues, by 2040, the Great Red Spot will become circular, or it may disappear altogether. The storm isn't only getting smaller, it's also growing taller and getting a more intense orange hue. It's not completely clear why it's happening. Might be because of a chemical reaction. It occurs when some new material rises to the top layers of the atmosphere from below. The Great Red Spot might be the most famous storm in the solar system, but it's by no means the only one. Even on Jupiter, there's a bit less known Little Red Spot, one more anticyclone but smaller in size. Well, when I say smaller, I mean the thing's not as large as its big sister, but it's still about the size of Earth. Recently, the highest wind speed inside the Little Red Spot has increased up to 400 miles per hour. A storm as wide as our planet rages on Saturn. It's called the Great White Spot. The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so, when Saturn's northern hemisphere tilts toward the Sun. This storm indeed starts as a spot, but then it stretches in length. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the peak of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White, it's where it gets its energy from. Some scientists think it may be powered by the Sun. Others argue that the storm's cloud pattern only makes sense if there's an internal heat source that can power the winds. Great dark spots on Neptune are massive storms that form in areas with high atmospheric pressure. That's different on Earth. Here, storms appear when the pressure is low. Around the spot's edges, the wind speeds can reach 1,300 miles per hour. Astronomers have observed 6 dark spots on Neptune so far. These powerful storms get born deep in the planet's atmosphere, and the darker a storm is, the brighter the methane clouds around it are. Another monster-sized storm raging on Saturn looks pretty much like a hurricane or typhoon on our planet. It has an eye and spiraling clouds surrounding it. But compared to Earth's hurricanes, the one on the ring planet is titanic. On Saturn, the eye of the storm is up to 1,250 miles across. The bright clouds closer to the edges of the hurricane are moving at a speed of 330 miles per hour. But one of the most unusual things about this storm is its shape. It has 6 sides and is known as the hexagon. When astronomers saw the first images with the vortex, they did a double take. The thing was just too similar to our storms. And still, the one whirling on Saturn has an eye that's almost 20 times larger than any people have seen on Earth. The storm also moves 4 times faster than hurricane winds on our planet. Saturn's atmosphere has little water vapor. How the bizarre hexagon storm is getting by in such conditions is a mystery. Plus, unlike the constantly drifting hurricanes on Earth, the one on Saturn seems to have nowhere to go. For some inexplicable reason, it's stuck at the planet's North Pole.
You're standing in a room full of explosive gas. One spark could cause an explosion so powerful that all the windows and doors would be just blown out with a huge column of fire. And you're holding a match. You need a bigger target than this room. How about the largest room of explosive gas in our entire solar system? Meet Jupiter. It's the 5th planet from the Sun and the largest one in our system. It's 11 times the width of Earth and almost 2.5 times heavier than all the other planets in our solar system combined. If we put Jupiter on the scales, we would need about 317 Earths to balance it. But most importantly, it has a lot of methane in its atmosphere. It's the gas we use in our kitchen or fill up our car with, and it burns just fine. More importantly, there's metallic hydrogen. In its normal state, hydrogen is the lightest element in the universe, but on Jupiter, it's at great pressure, more than 400 million atmospheres. By comparison, on Earth, you feel the pressure of 1 atmosphere. So multiply that by 400 million, and hydrogen is compressed so much that it looks like liquid metal. Metallic hydrogen can be a great fuel. It'll give off 20 times more energy than burning ordinary hydrogen. So you and your match can have great fun out there. Okay, here we go. The first problem is distance. Jupiter is only 1 planet away from us, but the path is also blocked by the asteroid belt behind Mars. It's full of giant rock debris. On average, each asteroid could be as wide as the distance from Los Angeles to Las Vegas. There's rocks the size of an entire state. And the biggest asteroid of them all is Ceres. It's almost as wide as Alaska. It's even considered a dwarf planet. And this dangerous journey to Jupiter takes about 650 days. That's almost 2 years of boredom inside a spaceship. By comparison, the longest time astronauts have spent aboard a spaceship is 84 days. But we'll let you take your favorite DVD collection and a couple bags of popcorn. At the end of the day, you'll be able to get some sleep after a hard day at work. Fast forward 2 years into the future, and you've arrived at your destination. You're already imagining lighting a match at the surface of Jupiter, exploding it like a balloon. Oh, be careful when you get close to it. Because of Jupiter's great weight, it has a strong gravitational force, about 3 times stronger than back home on Earth. The closer you get to its surface, the weaker you feel, and you can even barely stand on your feet. The maximum weight you can lift here is also 3 times less, and even a match you're holding in your hand already feels heavier. If you try to jump up, you need more effort. Actually, you can't even do that because Jupiter is a gas giant. That means it has no solid surface. Theoretically, the deeper you dive into these clouds, the more pressure you'll feel. Gradually, the clouds and gases thicken and form a kind of liquid. But you don't have to dive that deep. Methane is a light gas, and it's closer to the surface. So, this is the moment of truth. You take a match, you flick it on the box, and nothing happens. Well, let's give it a couple more tries. Second match. Third. Nothing works. Okay, you've got a gas burner in your backpack. You unscrew the valve to maximum, and nothing happens again. Well, that's because it takes 3 components to start the combustion process. The first is fuel. Luckily, there's enough methane and metallic hydrogen on Jupiter to blow up the whole planet in a matter of seconds. The second component is the ignition source. It's the initial force that will start the combustion process. It could be a spark, an electrical discharge, or a match like the one you have in your hand. And the last ingredient is oxygen. Yes, the same oxygen that we breathe. It's just as important to fire as the fuel itself. For an experiment, try lighting a small candle. Now cover it with a glass. You see how the fire keeps burning for a few seconds and then goes out? The fuel is still there, but the fire has used up all the oxygen inside the glass, and the burning process is over. The same thing happens on Jupiter. There just can't be fire, simply because there's no oxygen. And you didn't even have to fly there to find that out. From Earth, we can see hundreds of thousands of little meteorites falling on Jupiter. The asteroid belt next to it is to blame for this. When they hit its atmosphere, they start to burn, and that doesn't instantly blow up the entire planet. But don't be upset. There's still a way to ignite this gas giant planet. All you have to do is trigger a thermonuclear chain reaction on the planet. Then, there'll be an explosion so powerful, it'll be visible from Earth, and it will be like the birth of a new star. To do that, we need to detonate a nuclear reactor, like the ones that give us electricity here on Earth. In fact, we'd have to send everything we have to Jupiter, but even that won't do the trick. Big asteroids, when they hit the planet, cause a much bigger explosion. In 2009, a meteorite the size of 5 soccer fields hit Jupiter. It caused an explosion of 5 billion tons of TNT. This incident left a dark spot the size of the Pacific Ocean. And an even bigger explosion happened there in 1994. After that collision, there was a giant spot on Jupiter almost the size of our planet. But strong winds and storms quickly began to sweep away the traces of the explosion. After a few weeks, Jupiter looked like normal. The problem is that our attempts to blow up the gas giant took place on the planet's surface. We need to plant a charge the size of the moon deep below. A massive explosion will cause a thermonuclear reaction and cause the metallic hydrogen to detonate. The explosive process is set, and within seconds, Jupiter explodes like a giant balloon. But this spectacle will be the last one that humanity ever sees. The explosion would disturb the stable orbits of Earth and the other planets. The trajectory of Earth around the Sun might change, and we may see the dawn not in the east, but on any other side of the world. When the strong wind from the explosion reaches the Earth, it'll start scraping our atmosphere. Soon, our planet will lose its ozone layer. It was our shield that protected us from solar radiation. In such a situation, we'll have to hide underground for the rest of our lives. But even this can't protect us. Before long, the Earth will be showered with thousands of meteorites. Jupiter was so heavy that it held the asteroid belt in place. Without it, the asteroids would start flying towards us. Earth would feel a constant meteor shower. But there would be no one left on Earth to observe it anymore. Jupiter's explosion can be compared to a supernova. In fact, Jupiter is practically a star. If it were just a little bigger and heavier, it would start to shrink. The intense pressure on the planet's core would start thermonuclear reactions. Eventually, Jupiter will have turned into a brown dwarf, and it would be 50 times heavier than it is now. But because it doesn't have enough weight to do that, Jupiter is sometimes called a failed star. Well, maybe we should visit other gas planets in our solar system and try to light our match there. Saturn. Saturn's atmosphere is similar to Jupiter, but there's no oxygen for combustion there either. So all you have to do is admire the planet's beautiful rings and move on. Well, Uranus and Neptune are much smaller, and they don't have metallic hydrogen, so their explosion wouldn't be as strong. But you still wouldn't be able to ignite them with a match, because there's no atmosphere full of oxygen. But there is one planet where you could light a fire with your match. It's GJ1132b, and it's 39 light-years away. Scientists think it might have oxygen on it, although it's not a gas giant that has combustible gases in its atmosphere. But you can still sit on its rocky ground and make a fire to admire the unusual sunset.